All right, so this is exciting. We are at our last lesson. This is topic 1, where, as promised, we're going to talk about exponential functions and the formulas that we use to derive them. And then topic 2, we're going to talk about logarithms, and then we are done with this section. So let's go straight to this other page here. And I have written out for us really the two formulas that describe any type of exponential function we might encounter. The most generic one is the one I have in red here. And so it says the derivative with respect to x of a to the u. And just like we talked about in the last, trying to think, was it in, yes, I guess it was in lesson 8. We talked about the inverse trig functions and how now that we know the chain rule, they're going to give us the rules using, kind of involving the chain rule as we go. So instead of saying that we could have a exponential function a to the x, we're going to say a to the u, because chances are it won't be a to the x, it'll be a to the 2x or a to the 5x or a to the negative x or any version. It could be a to the sine of x. That would be really exciting. So we're going to talk about it in those terms, like a to the u, not a to the x. And then after we talk about that, we'll look at e to the u and see how that actually is an especially awesome function. And I alluded to this at one point in class, but we'll talk about it again today. So to get started, let's talk about the formula that we would use to derive any, and this actually works for even an e to the x or an e to the u type of function. Any exponential function can fit into this form, where the base is what they're describing as a, so that's a number, some like constant, 2 or 10 or e or any type of constant is going to be the base number, and then the variable is going to be found in the exponent, because of course that's why we call it an exponential function. So without further ado, here is the formula. So the derivative of a to the u is a to the u times the natural log of a times the derivative of whatever inside function we have. So if it's just x, then that just becomes 1 and we ignore it. But if it's something like 2x or 10x or sine of x, then we would multiply by that. That's basically the chain rule again. So a to the u natural log of a times the derivative of the inside function. And that's it. That's all you need to remember. Now here's what is so cool about exponential functions that involve e. We really can use the same formula that we have up here, just wherever we see a, we would put the constant e, the Euler number. And so instead of a to the u, it would be e to the u times the natural log of e, because that's what a is here, times du dx. So it's basically the same formula. But we know that the natural log of, the natural log in general is basically a logarithm with a base of e. So whenever we take a logarithm with the same base as the value that we're operating on, so basically, let me write that out because you probably haven't seen logarithms for a while. We're basically saying log base e of e. Anytime we do that, all we really are going to get as an answer is 1. And the reason is, remember, logarithms are how we find an exponent. So we're saying a logarithm, log base e of e means what exponent, that's what logarithms ask, what exponent would turn e into e? Well, an exponent of 1, right? E to the 1 would equal e. And so that's why anytime we have a base and the number that we're operating on the same, the answer is just 1. So this actually is not important. Really, the derivative of e to the u, let's just rewrite it just for fun, is just e to the u, du dx, whatever the inside function is. So here's why that's so exciting and awesome. If I were to have, let's take a different page here, if I just had the function y equals e to the x, and we wanted to derive it, so we're moving down our little ladder of derivatives. So we're going to derive y. The answer to y prime is just e to the x. and we derive it again. We get y double prime. The answer is still e to the x. We do triple prime, still e to the x. It doesn't matter how many times we derive, we get the same answer. And as I mentioned kind of as a little aside during class, what's so exciting about that is that what we're saying is that the graph of e to the x, which looks basically like that, is structured in such a way that whatever your position is on the graph, it is also your slope. So if the position, the y value is 1, well, actually, it wouldn't be 1 there because it would be, well, yeah, let's just say, if your position was 1, your slope would be 1. If your position was 2, your slope would be 2. If your position in the y direction is 10, your slope would be 10, and so on and so forth. So that's kind of a cool thing about e to the x, and that all comes from this formula here. So this one is important in the red, and then the one at the bottom, the simplified version, is important down in the blue. Those are your two equations. Let's just quickly see how we apply that to an actual problem. Let's say we have this as an example. We want to find the derivative with respect to x of e to the 2x plus 2 to the 3x. And here we see, it kind of reminds us of the difference between an exponential function with a base of e versus an exponential function with a base of some other constant. Here it's 2. So for this first part, we're going to look at our formulas. We know we're going to use the latter one because it's an e function. So if I have e to the u, the derivative is just e to the u times the derivative of the inside function. So let's look here. Derivative of e to the 2x would just be e to the 2x times the derivative of what's inside, 2x, which is just 2. So e to the 2x times 2, down on the bottom, right? We're just multiplying here. It's not part of the exponent. Then we look at the second part because we know when we derive, we can just break it into two pieces. I'll do it in green so we see the difference. 2 to the 3x, that's going to fit into our first equation, where our a value is 2 and our u is the inside function, which is 3x here. So looking at this, we're going to have 2 to the 3x natural log of 2 plus the derivative of the inside function. So writing that out, it would be 2 to the 3x times the natural log of 2 times the derivative of the inside function, which is 3. And if I want to write that all out as one kind of in its most clear ordering, I would probably say 2e to the 2x, because that looks a little bit better, plus we'll say 3 times 2 to the 3x natural log of 2. And that's not the only way you could write it, but that to me is probably about as clear as it can get, so we make sure we keep these three pieces separate. That's it. That's how we take the derivative of an exponential function. So I will leave that there, and we will pick up with logarithms in the Topic 2 video.